On the next page is a table where you can practice these compositions of functions using the symbolic representation. Here we have three different functions. F of x is 3x minus 5, g of x is x minus 5, h of x is x squared minus 5x. We'll look at evaluating the expression, writing the parentheses notation, substituting the inner function into the outer function, and simplifying the answer. Notice that different things are filled out in each one of these rows. And so the first two columns primarily, this last one is kind of interesting. We'll be able to backtrack to get all of those cells filled in. So what I want you to do is make sure you try these on your own before you come and check the answers. So if you're at this point right now, pause the video, try number 5 on your own. You can resume, I'll talk you through it, and we'll do that for each one of these problems. But do make sure that you pause in between each problem so that you can have immediate feedback on your work and be able to check yourself. 2 examples up top to get you started. One with a number instead of x, and the other one with x itself. One thing I will point out with this, when you have a number instead of x, you get a numerical answer. When you have just x, provided that the functions cooperate, that the functions will lend themselves to another function with x in it, you end up with a new function with x in it. So definitely something to point out and notice. A number in for x, you're going to get a number answer, period. Let's take a look at number 5. And again, pause that video, resume when you're ready, check your work. Let's go through number 5. F circle g of x. Our parentheses notation just means that we put g of x inside the parentheses of f. And then in the third column, f of g is x minus 5. F is 3x minus 5. So we'll take this g function and put it in for x. And then we simplify. So now multiplication, 3x minus 15 minus 5 on the end. Simplifying like terms, 3x minus 20. And so our simplification of the answer is really just a restatement. You can use either notation at this point, but I'm going to use the parentheses notation. F of g of x equals 3x minus 20. Try number 6 on your own, pause that video, resume when you're ready. In number 6, going backwards one to the first cell, if I have a parentheses notation here, to change it into the circle notation, I keep the same order, h, g, and x. The difference here going from parentheses to the circle notation, I put the circle between the two function names. And then g is x minus 5 again. And we're going to put x minus 5 into h, and h is x squared minus 5x. So x squared minus 5x. But for that g function, we're going to drop it in both places that have the x in it. And then we simplify. X minus 5 squared, we can do the box multiplication again, or recognize that it's a perfect square trinomial, x squared minus 10x plus 25. If you need to do that off to the side, absolutely do that off to the side. And then negative 5 distributed negative 5x, negative 5 gives me positive 25. And then I need to simplify it. So x squared, I don't have any like terms. Negative 10x, negative 5x will give me negative 15x. And then 25 and 25 will give me 50. And I can write h of g of x is x squared minus 15x plus 50. Number 7, we did one previously a lot like this. F of x. So we'll take the f function, 3x minus 5, and put it inside itself. So 3x minus 5. But this time I'm going to put that 3x minus 5 in where x used to be. And now we simplify. Distribute the 3, and we end up with f of x is 9x minus 20. For number 8, we have to work backwards. So notice what's written here. This would be this second column where we have parentheses notation, g of h of 6. Parentheses notation, going back to circle notation, just means we put a circle between the two function names. I have a 6 instead of an x, so I'm going to put the 6 in where x should go. And then it's a matter of using the function expressions to now find out how g of h of 6 is actually 1. So g of h of 6, we cannot use the function that we found in number 6 because notice the order h of g, and number 8 is g of h. The order is very important here. It causes different functions to happen, so I do not get to use number 6 to help me with number 8 at all. What I can do is take these into pieces. I can look just at h of 6 first. H is x squared plus 5x. No, it's not. It's x squared minus 5x. So where the x's were, I'm going to put parentheses. But now I'm going to put a 6 in there because h of 6, I need to plug in 6 for x. 6 squared will give me 36 minus 30 gives me 6. So now I plugged in 6 for h, but I need an answer for g. So I need g of h of 6, but h of 6 was 6. I need g of 6. So I'll put this here just to show us that substitution of going back in. The 6 in pink is not the same 6 that we have at the beginning. We could have gotten a different number depending on what h was. So g of 6, g is x minus 5, x minus 5. So 6 minus 5 would give us 1. And that's exactly the answer that we were given, and that's how it works out. G of x, we can first change it to parentheses notation. G is x minus 5, so I have x. I'm going to first put in x minus 5 here for the first g inside the parentheses. And now for the outside, g x minus 5. But the x minus 5 in parentheses gets dropped into that function where x was. And now we simplify. X minus 5 will give us x minus 10. And we would say g of x is x minus 10. And one more problem in the table that spilled over onto the next page. The same idea here as before. We have the parentheses notation h of f of 2. For the circle notation, keep the same order. Just put the circle between the two function names, and then we'll keep the 2. Plugging things in, I can first plug 2 into f and determine what that is. F was 3x minus 5, so instead of 3x, we'll put a 2. 3 times 2 is 6. 6 minus 5 will give me 1. And now I'm going to take f of 2 and plug it into h. Notice f of 2 all together turns into 1 because f of 2 and 1 are the same. H of 1, h was x squared minus 5x, so we'll put in a 1 there. 1 squared minus 5, so 1 minus 5 actually gives us negative 4. And we would say h of f of 2 is equal to negative 4.